How many of you know the film Godzilla? Oh wow, okay. That's really good. You will hear about it actually. I'm pretty happy to see this because this is one of my favorite movies and one of very few that I have seen more than once. And for those who don't know the film, Godzilla is this enormous prehistoric sea monster awakened and empowered by radiation. And it has the yeah, right. It has the ability to produce a radioactive laser-like beam from its mouth and attack people. Who wouldn't be afraid and who would not want to hide? And metaphorically speaking, dark matter would want to hide from Godzilla too. And the reason is not that it's enormous and scary, but the reason why dark matter would want to hide is that Godzilla is radioactive. And even if Godzilla was this big, dark matter would still want to hide because it's radioactive. Yeah, so pretty scary thing, right? And now you might think, okay, Godzilla is probably not real, what am I speaking about? I mean, I'm a paid scientist and I'm speaking about a monster that's most probably not real. But the thing is that I don't know. The thing is that there is much more radioactivity around us than we actually can see or feel. So imagine going on a walk on a Sunday afternoon, maybe a little bit nicer than today. Imagine it's like sunny and the birds are singing, and it's a really nice walk. But what you might not realize is that with every breath you take, you breathe radioactive gas radon in. Really bad, right? It makes you feel like I should stop breathing or something. During this walk, the ground you're walking on is also radioactive because it contains radioactive uranium. And last but not least, there are the so-called cosmic rays that are traveling from the space towards the Earth, reacting with the particles in the Earth's atmosphere and producing radioactive particles that literally fell onto our heads during this wonderful walk. So I actually went on such a walk last week, not this week because it was rainy, but I went last week here in Canberra, Burley Griffin, and I took with me a radioactive snack. And I'll tell you a secret. I smuggled exactly the same radioactive snack in here tonight with me. And I'm going to show it to you. So I would ask the first row to be a little bit careful, maybe lean forward when I'm going to take it out. What do you think is it? Does anybody have McDonald's burger? Yeah, that's a very good guess. Any other guesses? What it could be? Something radioactive you can eat?
Plutonium.
Oh, I actually heard it already. It's not plutonium, but this gentleman in front row was right. It's a banana. Now, how many of you are afraid of this banana? Okay, we have 2 people, which is 2 more than I expected. And I have to admit, there is not really much scary stuff about this banana. Yeah, it's just a banana. And, you know, it's radioactive. Who can actually tell me why it's radioactive? Does anybody have any idea what it contains that might be radioactive? Oh, wow, potassium. Okay, so this seems to be a well-known thing, right? I was going to give this banana to the person who knows this secret. And I'm going to have to cut it in a few pieces. Anyway, maybe eat it myself. But as a matter of fact, you don't really have to be afraid neither of this banana nor of all these things I named that are radiating onto you during the walk. You would actually have to eat 10 million bananas in order to receive a lethal dose of radiation. That's quite a lot. Yeah. But let's go to my next slide. It's working. Who is afraid of this banana? Fair enough. I mean, the artist here made a really good job in my opinion because this banana is literally scary. I actually don't even want to look at it. It's a really scary one. And in the eyes of dark matter, this banana would look like this and would have a size of a Godzilla. And the reason is just the radioactivity. So why is it that in the eyes of dark matter, even the tiniest amount of radioactivity looks like a monster, like a Godzilla? Even though for such vulnerable beings as humans, it's not dangerous at all. So the reason for this is that radioactive substances decay and produce particles. And when we try to detect dark matter, the amount of these particles from radioactive decays is huge. It's just enormous, so much bigger than the amount of dark matter that we can see. Dark matter is very, very shy. So we are trying to detect this mysterious dark matter. Maybe I should actually tell you a little bit about it. So do you know why it's called dark matter? Does anybody have an idea? So scientists have been speaking about black holes, dark energy. Yeah, it's invisible. That's very close. It's dark. You can't see it. It doesn't interact with any electromagnetic field. It doesn't absorb light. It doesn't emit light. It just does nothing. You can't literally see it. But what you can see is its gravitational influence on objects like galaxies. When you have a look at galaxies, and we can pretty well look at galaxies these days, you can see that the outer sides of them rotate much quicker than they should according to the physics laws that we understand these days. So why is it? We don't know, but we know there must be some sort of mass that contributes to this what we don't see, so we call it dark matter, mass, which is there, and it's unbelievable 85% of the mass of the universe. And this means that we only understand 15% of the mass in the universe. And now imagine what great stuff we can already do in physics, biology, medicine, and there is a huge list of stuff that we can already do only knowing 15% of the universe. And now imagine this huge potential. What could we do if we knew the other 85%? I can't even tell you. If you ask people 300 years ago, what are you going to do with electricity? They couldn't possibly tell you because they couldn't imagine. If you told someone 100 years ago, what do you do with unlimited internet? They wouldn't tell you, I'm going to watch Breaking Bad on Netflix, right? They just wouldn't know. So I can't really tell you what we want to do with this dark matter when we discover it, but I can tell you that there is so much potential that is definitely worth it. Let me put this banana down. Anyway, it's very scary. But the reason why we go underground to this laboratory that I mentioned in the beginning of my talk is that going underground prevents this radioactivity to produce these particles that might mimic the dark matter. In this picture you can see the Stoll laboratory. On the left side you can see the driveway. So we drive there with a car. It takes several minutes, it's several kilometers. It's actually very hot environment, it's 50 degrees Celsius. But thankfully we have air conditioning, which cools everything down to pleasant 23 degrees. And this is the area where we are building our experiment, where we actually want to hide from all these radioactive monsters on the surface of the Earth and detect the dark matter particles. And there is one more thing actually that I want to mention, which is the focus of my research. I told you about these Godzillas or monsters or whatever you want to call all these radio impurities. And the thing is that they can hide anywhere. They can be even tiny. You know, anything radioactive, even this banana, can contain enough radioactivity so that it produces decays and prevents us from identifying dark matter. If my boss actually saw me with this banana, I might lose my job. Imagine me taking this banana down there and talking to media. That's what we have been doing quite many times, you know, talking to media. And if I was like in the background holding this banana, I don't know what I would do. I would probably really lose my job. And I really like my job, so that wouldn't be a very good thing. But anyway, I want you to remember 3 things from my talk tonight. The first one is dark matter is believed to be everywhere around us, 85% of the mass. The second thing is, dark matter is shy. It barely interacts with anything. If there is one dark matter particle that we can detect per day, we would already be happy. And there are so many radioactive decays that, and now we go to the third thing, that we have to hide somewhere from these radioactive monsters. And we can go underground. And this is the environment where we can actually, with proper shielding, with proper detector and technology that you will hear about from my colleagues, detect this mysterious dark matter And I'm really hoping that next year, because this experiment will actually start in the middle of the next year, and I'm hoping that next year in Dark Matter in the Pub, I'll be able to, tell you what we can actually do with this. Not electricity, not internet, but, this dark matter. Thank you very much.